So these are the masking and demasking agent. So masking agent is particularly used for determination of mixture of metal ions present in an analyte. It will form mask or cover over unwanted chemical species, that is unwanted metal ions, and it will not interfere into the analysis. Example of masking agent is triethanolamine. It is used for masking of Fe, Al and Sn. Second example of masking agent is the fluoride. It is particularly used for masking of Fe and Al. Third example of masking agent is the iodide. It is particularly used to cover up or mask the Hg entity. Second is the demasking agent. So demasking agent is a technique of releasing the masked species so that it is free to react with the principal reagent. Here the principal reagent will be the complexing agent. In a mixture of metal ion, after determination of first metal ion, we are going to add demasking agent. After addition of demasking agent, the second metal ion which is covered one or which is masked one, that is free to analyze. So that is the main use of demasking agent. It will set free the second masked metal ion whose concentration is to be determined. So best example of demasking agent is a mixture of formaldehyde and acetic acid. So these are the masking and demasking agent used in complexometric type of titration. Next is the what are the ideal requirements of masking and demasking agent. First requirement, that is it should be readily reacted by precipitation, that is it should form easily stable complex with that of the unwanted chemical species. It should easy to react, it should be easy to form stable complex with the unwanted metal species. And third is the color developed by this agent should not interfere with the end point of titration. म्हणजे जे काय कॉम्प्लेक्स तयार होणार आहे बिटवीन अनवॉन्टेड मेटल स्पेसिस अँड मास्किंग अँड डेमास्किंग एजंट आणि जे काय कलर डेव्हलपमेंट होणार आहे दॅट शुड नॉट बी सिमिलर टू दॅट ऑफ एंड पॉइंट ऑफ titration. So these are the masking and demasking agent. Next point of complexometric type of titration is the application of complexometric titration. Complexometric type of titration, first application is it is particularly used for determination of hardness of water. So first we should know what is hard water. Hard water is nothing but the water which contains metal ion in it. Say for example chlorine, calcium, magnesium, aluminum. हे जे काय मेटल आयन्स आहेत हे जर मेटल आयन कंटेनिंग वॉटर असेल सो दॅट इज नोन एज हार्ड वॉटर and that is not fit for consumption. So firstly the tap water, it is to be determined for presence of metal ion. If it contains permissible amount of metal ion, then it is fit for consumption. And if the quantity of metal ion is more than as that of the standards, then it is not fit for consumption. So determination of hardness of water can be done by complexometric type of titration. Secondly, we can able to determine the goal ions present in an ores. Complexometric type of titration is also used for determination of metal ions, that is the uric ions in urine. So it is particularly used for determining it is used for prognosis of the kidney disorder. Next application of complexometric type of titration is it is used for preparation of calcium assay, that is एखादा ड्रग सबस्टन्स कंटेनिंग कॅल्शियम मध्ये त्याचं पर्सेंट प्युरिटी किती आहे दॅट वी कॅन बी एबल टू फाइंड आउट बाय कॉम्प्लेक्सोमेट्रिक टाइप ऑफ टायट्रेशन. Nextly, it is also used for determination of magnesium sulphate. Magnesium sulphate had drug substance की percent purity किती आहे that we can be able to determine by complexometric type of titration. And lastly, it is used in determination of aluminum glycinate. So these are the application of complexometric type of titration. So first application, it is used to determine the hard water. Hard water is nothing but the water which contains metal ion in it, either in the form of metal ion, either in the form of calcium, magnesium, and aluminum. If the water contains an more amount of metal ion in it, it is not fit for consumption. So for determining the hardness of water, complexometric type of titration is used. Nextly, Gold ions in ores can also be determined by complexometric type of titration. We can be able to find out the concentration of uric ions in urine. That is, it is particularly used in prognosis of kidney disorder. It is also used to check the percent purity of drug substances containing calcium ion in it. It is also used for determination of the magnesium sulfate and determination of aluminum glycinate. So next and last part of complexometric type of titration is the assay procedure of calcium gluconate. Since it contains metal ion, that is calcium in it, we are going to determine its concentration by complexometric type of titration. So estimation असेल किंवा assay procedure असेल कुठलाही drug substance ची. So what does it represents? So assay procedure of any drug substance represents the percent purity. That is, it should not be less than 99 point and it should not be more than 101 point. ह्या दोन्हीच्या in between मध्ये त्या assay procedure ची value यायला पाहिजे. So assay is nothing but it represents the percent purity of the drug substance. Since nature of calcium gluconate, it contains metal ion in it, we are going to perform it by complexometric type of titration. So कुठलाही assay मध्ये किंवा standardization procedure चे steps किंवा bits हे common असतील. First असणारे principle, followed by assay किंवा standardization procedure, followed by reaction, reaction च्या नंतर factor. So firstly we will study principal part of calcium gluconate. Principal part मध्ये कुठलं type of titration आहे, extra reagent कुठलं use केलेलं आहे, इंडिकेटर कुठला यूज केलेला आहे आणि एंड पॉइंट काय आहे, हे सगळे बिट्स कव्हर अप होतात. सो प्रिन्सिपल ऑफ कॉम्प्लेक्सोमेट्रिक टाइप ऑफ टायट्रेशन इट कम्स अंडर principle of calcium gluconate, it comes under complexometric type of titration, that too replacement type of titration. As seen earlier, complexometric type of titration is categorized into 5 major classes. Direct असेल, replacement असेल, alkalimetric असेल, indirect असेल. So estimation of calcium gluconate comes under replacement type of titration. Here extra reagent used in calcium gluconate assay procedure मध्ये, that is magnesium sulphate. Magnesium sulphate है extra reagent use केलेला आहे. Indicator used is modern black second. Standard solution used is complexing agent, that is disodium EDTA, and in a concentration of 0.05. So what is the principle? It is an complexometric type of titration which involves the replacement of magnesium ions from magnesium indicator complex. Nextly, modern black second is used as an modern black second which is used as an indicator and do not give distinct color with that of the endpoint with the calcium. So calcium assay procedure of calcium gluconate मध्ये we are going to use modern black second as an indicator, but calcium is not able to form first complex with the indicator. Therefore, we are going to add extra reagent, that is Therefore, we are going to add extra reagent, that is magnesium sulphate. So firstly, there is formation of complex between Mg and indicator. Therefore, it is therefore a known volume of MgSO4, that is 0.05 molar. We are going to add it into contents in conical flask containing calcium gluconate, which is present into the solution. So firstly, contents in conical flask will be calcium gluconate. Nextly, we are going to add extra reagent, that is 0.05 molar of magnesium sulphate. Nextly, we are going to add water, warm water as a solvent. And lastly, we are going to add indicator, that is modern black second is used as an indicator. And basic part in complexometric type of titration is we are going to perform complexometric type of titration in a pH of 10. What is the use of pH of 10? pH 10 is used to maintain the condition alkaline in order to form stable complex between complexing agent and metal ion. So contents in conical flask will be the analyte whose concentration is to be determined, that is calcium gluconate. For dissolving purpose, we are going to use warm water. Nextly, extra reagent added is magnesium sulphate in a concentration of 0.05 molar. Next is the indicator, that is modern black second. And last is for maintaining the conditions alkaline, we are going to add ammonia buffer. We are going to maintain the pH at 10 by adding ammonia buffer in order to maintain the stability of complex which will be formed between the metal ion and standard complexing agent. So these are the contents in conical flask. On principle मध्ये कुठला type of titration आहे, replacement आहे. Replacement का बर, initially there is formation of complex between the extra reagent, that is Mg and indicator. Calcium is not able to form direct complex with the indicator. So firstly there is formation of complex between Mg and indicator. So when we are going to add 1 ml of standard diazonium EDTA from burette to contents in conical flask, all of the calcium has been consumed by complexing agent and no more calcium will be available in conical flask with the standard solution of diazonium EDTA. And when excess amount of diazonium EDTA is added from burette to contents in conical flask, since calcium is not available in conical flask to react with the EDTA, then EDTA will react with the Mg entity, that is second metal ion entity present in conical flask. So dissociation of complex between Mg and indicator takes place and all of the Mg will be consumed by the diazonium EDTA. So indicator will set free to react with the calcium. So calcium will then react with the indicator and end point of titration will be reached one. So this is the basic principle of calcium gluconate that comes under replacement type of titration. Next आहे procedure, that is standardization procedure. Standardization procedure मध्ये exactly किती quantity घेतली आपण. So we have taken 0.5 gram of analyte, that is calcium gluconate, whose concentration is to be determined. Nextly, for dissolving purpose we are going to use 50 ml of warm water. Warm water का use करायचा, since nature of calcium gluconate, it is amorphous in nature, it is not soluble in plain water or normal water. Therefore we are going to use warm water. We are going to cool down the contents. After cooling down the contents, we are going to add known volume of magnesium sulfate. Here we know the volume of magnesium sulfate, that is 5 ml of 0.05 molar. So extra reagent added in case of calcium gluconate determination is the 5 ml of 0.05 molar magnesium sulfate. Nextly, we are going to add 10 ml of strong ammonia solution in order to maintain the conditions alkaline. So this will be the contents in conical flask, that is calcium gluconate, water, magnesium sulfate, strong ammonia solution, and last is the indicator. कुठले indicator use केलेला आहे? Indicator used in case of determination of calcium gluconate, modern black second. So nextly we are going to add 1 ml of standard solution, that is complexing agent from burette, which we have prepared in a concentration of 0.05 molar diazonium EDTA from burette to contents in conical flask. तर initially conical flask मध्ये calcium free आहे to react with EDTA, so it will form complex with the EDTA. Here the reaction has been depicted, that is calcium gluconate reacts with EDTA, formation of calcium EDTA complex takes place. Nextly, when all of the calcium has been consumed by EDTA, the excess drop of or excess amount of EDTA will then react with the magnesium entity of magnesium sulfate, and the जे काय complex firstly तयार होणार आहे Mg आणि indicator मध्ये, that will get dissociate out due to dissociation of complex. The calcium will then set free to react with the indicator, that will indicate the end point of titration. So we are going to add 1 ml of diazonium in EDTA until color changes from pink to blue. Initially the pink color in contents in conical flask due to the formation of complex between MgSO4 and modern black second. When excess amount of, when all of the calcium gluconate has been consumed by diazonium EDTA, then excess amount of diazonium EDTA will react with the MgSO4 and the modern black second complex. Therefore, this pink color will get disappear and it will get converted to blue coloration. So from the burette reading, subtract the volume of EDTA required for MgSO4. MgSO4 ने किती consume केलं त्याची value subtract करायची. This gives that this difference is the volume of volume required by calcium gluconate sample only and not that by MgSO4. So this is the determination process of calcium gluconate. It comes under replacement type of complexometric titration. Now moving on towards the last bit of complexometric titration is the determination of magnesium sulfate. It also comes, since it contains magnesium metal ion entity in it, it comes under complexometric type of titration, that too डायरेक्ट मेथड आहे, ह्याच्यामध्ये एक्स्ट्रा कुठला रिएजंट यूज करायची गरज नाही. therefore it comes under direct method of complexometric type of titration. So contents in conical flask will be aqueous form of magnesium sulfate. For maintaining the conditions alkaline, we are going to add ammonia buffer. Lastly, we are going to add indicator. Most commonly used indicator in case of complexometric type of titration is modern black second. Nextly, contents in burette will be 0.05 molar disodium EDTA. So we are going to add 1 ml of standard solution of EDTA to contents in conical flask containing magnesium sulfate. Formation of complex between disodium EDTA and Mg takes place. That is, Mg entity will react. This is the symbolic representation of complexing agent, that is disodium EDTA. Mg will react with the complexing agent. Formation of Mg EDTA complex takes place with the liberation of acid. A point will come that no more Mg will be available in conical flask to react with that of the complexing agent. That point is known as end point of titration, and that is indicated by the color change of contents in conical flask. त्या मोमेंटला डायसोडियम EDTA addition stop करा, burette reading note down करा. After noting down the burette reading, we will be able to find out the concentration of MgSO4. So principal part मध्ये it is a direct complexometric titration. Disodium EDTA is used as a titrant which forms complex with MgSO4 at a pH of 10, and pH of 10 is provided by ammonia ammonium chloride buffer, and modern black second is used as an indicator. So this is the principal part. Next आहे procedure. Procedure मध्ये exact quantity MgSO4 ची किंवा दुसऱ्या reagent ची. So quantity of MgSO4 taken in conical flask is 0.5 gram of analate, that is MgSO4. For dissolving purpose, we are going to use 50 ml of distilled water. Lastly, we are going to add 10 ml of ammonia, strong ammonia ammonium chloride solution. So this is used to maintain the conditions alkaline in order to maintain the stability of complex which will be formed between analate, that is MgSO4, and disodium EDTA. Nextly, we are going to add titrant, that is 0.05 molar disodium EDTA to contents in conical flask until all of the MgSO4 has been consumed by disodium EDTA. So color change at the end point is from faint pink color to blue coloration. So formation of blue coloration in contents in conical flask indicates the end point of titration, that is no more MgSO4 or Mg entity is available in conical flask to react with disodium EDTA. By noting down the burette reading, we will be able to find out the concentration of MgSO4. So this is the assay procedure of MgSO4. So with this, we have completed complexometric type of titration.